Imagine turning on your garden tap and watching it fill not from a hose, not from a pump, not from a single electrical component, just from the ground itself. Not a trick, not a rain barrel. A genuine, self-pressurizing water delivery system that has been running on the same farm in Lancaster County, Pennsylvania since 1931. No motor, no bill, no maintenance call. That is not a fantasy. That is Thursday morning for families in Holmes County, Ohio and Arthur, Illinois communities that have never paid a water pump bill in their lives. What you are about to learn is the exact system they use to move water from a source to a garden, a livestock trough, or a homestead without touching a single electrical circuit. And it starts with a $2 piece of pipe and a hole in the ground. Stay with me until the end, because the last technique I am going to share involves something most people throw away, and it is the piece of this system I have never seen documented in any modern homesteading guide. The average American household spends $840 a year on water and utility costs tied to irrigation and pressure systems. That is $8,400 over a decade and $42,000 over 50 years. Money flowing out of your account every month into the hands of utility companies that have spent decades making sure you never learned there was another way. What if the most effective gravity-fed water system ever designed was already perfected over 2 centuries ago, and the only reason you don't have one is because someone else profits from your dependency? Here is what we are covering today. Phase 1. Source. Reading how to identify whether your land has a viable gravity-fed source and exactly where it is, even if you've never found it. Phase 2. The pipe selection and placement method. Why the $2 pipe is not a metaphor, and the exact angle and depth that creates passive flow. Phase 3. The depth equation. The 3-number formula that determines your delivery pressure. Phase 4. Flow optimization. The Amish modifications that double output without adding a single mechanical component. Phase 5. The sealing system. The contamination prevention method that keeps this running clean for decades. And then the buried technique at the end, the one involving something most people throw away that turns this from a garden system into a full homestead water solution. Let's start at Phase 1. This is the phase that determines whether everything else works, and it is the phase that every other guide on this topic skips entirely. Before you buy a single piece of pipe, you need to confirm that your land has what engineers call a gravity head, a water source at a higher elevation than your delivery point. This sounds obvious until you realize that the source does not need to be a visible stream or pond. It can be a subsurface spring, a high water table seam, or even a natural drainage convergence that only flows part of the year. Here is how the Amish locate these invisible sources. Walk your land after a heavy rain, not during, after. Specifically, walk it 24 to 48 hours after the rain stops. The areas that are still damp, still soft underfoot, still showing surface moisture when surrounding areas are dry, those are your seep zones. That is where subsurface water is moving upward under natural pressure. Mark every one of those zones. Then check your topography. You need the seep zone to sit at least 18 inches higher in elevation than your delivery point. That elevation difference, that is what creates your pressure. You are not pumping. You are borrowing gravity. The detail no other video will give you. If your seep zone is less than 18 inches above your delivery point, the system will not sustain flow under dry conditions. 18 inches is not a suggestion. It is the minimum threshold below which atmospheric pressure and soil friction cancel out your gravity head. This is the section that separates a system that works from a hole in the ground. Now for the $2 pipe. And no, it is not a metaphor. What you are installing is a section of standard 1 5-inch diameter PVC pipe, the kind sold at any hardware store, cut to a length between 24 and 36 inches, depending on your source depth. But here is what every other video gets completely wrong about this pipe. It is not a delivery pipe. It is a collection sleeve. Its job is not to carry water to your garden. Its job is to intercept the subsurface flow, concentrate it, and feed it into your gravity line. That distinction changes everything about how you install it. The pipe goes in vertically straight down into the center of your seep zone. You are not drilling at an angle. You are not installing it horizontally. You are dropping it straight into the seep like a well point, except it only needs to reach 12 to 18 inches below the surface moisture layer. Before it goes in the ground, drill a series of 3 8-inch holes along the bottom 12 inches of the pipe. 16 holes, minimum 4 columns of 4, evenly spaced. These holes are your collection surface. Every one of them is a point where subsurface water enters the sleeve under natural pressure. The top of the pipe, above ground level, gets a tight-fitting cap with a single outlet point that is where your gravity feed line connects. This entire setup costs between $1.80 and $2.40 in materials at a standard hardware store. This is the formula nobody teaches, and it is the one that will determine your actual water output. 3 variables. You need all 3. Variable 1. Source elevation height. Measure the vertical distance in feet from the top of your collection pipe to the surface of your delivery point. Write that number down. Variable 2. Delivery line length. Measure the total horizontal distance in feet from your collection pipe to where the water needs to arrive. Variable 3. Pipe internal diameter. The relationship is this. For every 2.3 feet of elevation drop, you generate approximately 1 pounds per square inch of working pressure at the delivery end. That is basic hydrostatic physics. The Amish did not invent it, they just never forgot it when the rest of us moved on to electric pumps. A collection pipe that sits 4.6 feet above your garden tap produces approximately 2 pounds per square inches. That is enough to fill a drip irrigation system, a livestock trough, or a standard garden hose at slow flow. If you need more pressure, you do not need a bigger pump. You need a higher source, a longer drop, or a narrower delivery pipe, all free adjustments. The detail that every guide misses: the length of your delivery line creates friction loss that subtracts from your pressure. The rule is approximately 0.4 pounds per square inches of loss per 100 feet of 3 4-inch pipe. A 200-foot delivery line from a 4-6-foot elevation source gives you 2 pounds per square inches minus 0.8 pounds per square inches, so 1.2 pounds per square inches at the end. That is still functional for drip systems. But if you try to push that through a standard garden hose nozzle, you will be disappointed. Know your math before you bury your line. This is the phase where the Amish modifications separate a basic gravity system from a genuine Homestead water solution. There are 2 modifications. Both are free. Both were documented in a 1947 USDA extension survey of Pennsylvania water systems, and both have been quietly removed from every modern irrigation guide. Modification 1. The collection gravel pack. Before you set your collection pipe in the ground, line the hole with 3 to 4 inches of clean pea gravel on all sides. This gravel layer does 2 things. First, it prevents the surrounding soil from collapsing into your collection holes and clogging them. Second, and this is the part no other video will explain, the gravel creates a capillary break that actually increases the pressure differential at your collection surface. Water moves from fine-grained soil into coarse gravel faster than it moves through soil alone. Your collection rate goes up without changing anything else. Modification 2. The overflow return. Run a second, smaller pipe, 1 2-inch diameter, from a point 6 inches below the top of your collection sleeve back into the ground at a point 10 feet away from your source. This is your overflow return line. When your collection sleeve fills faster than your delivery system draws, instead of building back pressure that pushes water away from your sleeve, the overflow returns excess water to the water table at a safe distance. The system stays self-regulating. It never backs up. It never pushes back. It just runs. These 2 modifications combined can increase your delivery flow rate by 40 to 60% without adding a single electrical or mechanical component. But Phase 4 is only the foundation. Phase 5 is where the system either lasts 40 years or fails in the first wet season. This is the contamination phase, and it is the one that matters most. The threat is not bacterial contamination from your water source. If your source is a natural seep from a healthy water table, that water has been filtered through 20 to 40 feet of soil. It is cleaner than most municipal tap water. The threat is surface runoff contamination, rainwater, agricultural runoff, topsoil, bacteria, all of it can enter your collection sleeve from the top if you do not seal the above-ground portion correctly. The Amish sealing method is this. The top 8 inches of your collection sleeve, the section that runs from just below the soil surface to the cap, gets packed with hydraulic cement, not silicone caulk. Silicone shrinks and cracks. Hydraulic cement expands slightly as it cures, creating a compression seal against the pipe and the surrounding soil. That seal does not degrade, does not require maintenance, and does not fail in freeze-thaw cycles. The specific product is standard hydraulic cement, available at any hardware store for under $12 a bag, enough for 4 collection sleeves. Mix it thick, pack it around the pipe with a stick, and let it cure for 72 hours before running the system. One more detail. Run a 4-inch perimeter of compacted clay soil around the cement collar, sloped away from the pipe. Clay repels water. The slope directs surface runoff away from your collection point. Between the hydraulic cement and the clay collar, surface contamination becomes functionally impossible. This is the sealing system that has kept Amish gravity water running clean for generations. It is not in any modern plumbing guide. I have been sitting with that fact for a long time. Problem 1. No flow after installation. This is a soil timing issue. You installed the pipe in dry conditions, and the surrounding soil has not yet resaturated around your collection holes. The fix. Pour 5 gallons of clean water slowly around the base of your collection sleeve. This primes the capillary zone and restores the moisture gradient the system depends on. Wait 24 hours. Flow will begin. Problem 2. Flow starts strong, then slows to a trickle after a few days. This is a clogging issue. Fine soil particles have migrated into your collection holes. The fix? Back flush the system. Close your delivery line. Remove the cap from the collection sleeve and pour 2 gallons of water directly into the top of the pipe under pressure. This forces a reverse flow through the collection holes, clearing the blockage. Then reinstall the gravel pack if you skipped it the first time. You will not skip it again. Problem 3. Water has a sulfur or earth smell. This is a biofilm issue, not a contamination issue. Biofilm forms when water sits in a partially filled collection sleeve without regular turnover. The fix. Increase your delivery. Draw open the delivery line further, or add a second delivery point to increase daily flow volume. Stagnant water smells. Moving water does not. Problem 4. Visible water around the base of the collection pipe after rain. Your clay collar is not adequately sloped, or it has settled flat. Surface water is pooling against the cement collar. The fix. Add 3 additional inches of compacted clay in a 6-inch radius around the collar, sloped at a minimum 5-degree angle away from the pipe. Recheck after the next rain event. Problem 5. Delivery pressure drops in summer. Your water table drops in dry seasons, reducing the height of the subsurface flow relative to your collection holes. This is normal and expected. The fix. Deepen your collection sleeve by 6 inches by attaching a coupler and a second pipe section below the existing installation. This accesses a lower, more stable water table seam that maintains elevation year-round. Let me bring this all together. A self-filling, electricity-free water system, $2 in pipe, a hole in the right spot, and a system the Amish have been running since before any of us were born. Source reading: How to Find a Gravity Head on Your Land by reading soil moisture 24 to 48 hours after rain. Seep zones, elevation minimums, the 1/8-inch rule. The collection sleeve 1. Sex, 5-inch PVC, 16 collection holes, vertical installation. $2 at any hardware store. The depth equation, 2.3 feet of elevation, equals 1 pounds per square inch of pressure. Know your elevation. Know your line length. Calculate your friction loss. Build to the pressure you actually need. The two Amish modifications: gravel pack for capillary acceleration, overflow return for self-regulation, both documented in a 1947 USDA survey, both removed from every modern guide. The hydraulic cement seal the contamination protection system that makes this last 40 years instead of 4 seasons. And the buried technique, the overflow return line, used not just for regulation, but as a subsurface irrigation system for a raised bed placed directly over the return point. Your excess water does not go to waste. It feeds your garden. The system becomes a closed loop. $2 one afternoon. A water system that runs without you. If you have ever stood at your water meter in August, watching the number climb and wondering why something as fundamental as water still costs this much to move 10 feet across your own land, you now know there was always another way. This system does not require a permit. It does not require a professional. It does not require a single thing that the utility companies sell. It requires a reading of your land, a piece of pipe, and an afternoon. The Amish did not keep this secret to be clever. They kept it because it works, and because no one had a reason to take it from them. You now have it too. Drop a comment and tell me, do you have a seep zone on your property, or are you planning to test for one? I read every single one, and I want to know how many people are about to put a $2 pipe in the ground. If you found something real in this video, share it with one person who is still paying every month for something they could solve once. And if this is the kind of information you want more of, systems that work, that last, that cost almost nothing, you already know what to do. Subscribe to Ancient Roots. The next system goes deeper, and it makes this one look like the warm-up.